Unit 2C, Lesson 2, Building Functions from Existing Functions. In this lesson, we're going to take a basic function or graph of that basic function, and then we're going to perform transformations on that. Essentially, we're going to alter the graph through various means. Here's a table that organizes many of the different transformation rules that we can go through. The ones highlighted in yellow are going to be the ones we go through in this class. Okay, so the first one referred to vertical translations of the graph. Essentially, we're going to be shifting the graph up or down. So this is only going to affect the y values of all the ordered pairs of our original graph. Next, we have horizontal translations, and those are going to be left or right. This is just going to affect the x-coordinate of our original graphs. So either we're moving our graph to the left. If that value inside the parentheses is positive, we go to the left. If it's negative, we go to the right. The next transformation is going to be a reflection across the x-axis. So think of a mirrored image. We're just mirroring that across the x-axis. That occurs if we have a negative out in front of our function. And then the last transformations we're going to discuss are vertical stretches or vertical compressions. Lots of times, instead of compression, they'll say shrink. So vertical stretch or vertical shrink. It's going to be a vertical stretch if that value of a, the absolute value of a, is greater than 0. It's going to be a vertical shrink or compression if this value of a, the absolute value, is between 0 and 1. So make sure to highlight these ones that are highlighted on my screen. The other three, we'll get to those later. Here are a couple different graphs that highlight some of those transformations, so hopefully they make a little more sense. So first we'll talk about the one on the left. This is going to be a vertical translation, talking about that type of transformation. So if we started with our basic graph, f of x equals x squared, quadratic function in its basic form, the vertex at the origin, this is called the parent function. If we have a vertical translation such that we add 4 at the end of this parent function, the end of this equation, that just moves every point up 4 units. Okay, it just affects the y value. If we have that basic parent function, x squared, and then we subtract 3, that just means we translate this vertically down 3 units. So for adding a value at the end, moves the graph up. Subtracting a value at the end, moves the graph down. Off to the right, this is referring to our horizontal translations. So again, we start with that parent function, f of x equals x squared. If we have x plus 2 inside our parentheses of our parent function, just think about the confusion you had when we used that vertex form to identify the vertex. Think of this as x minus some value. So if it's x plus 2, this is the same as x minus negative 2. If it's negative 2, that means we're going to the left on the x-axis, so that's why we have a horizontal translation 2 units to the left. The one in green, we have x minus 3 quantity squared, so it's x minus, our value is 3, which means we move to the right 3 units on the horizontal, referring to our x values. So now to end this lesson, we're going to go through 4 examples where we describe the transformations of the graph from the basic function, also called the parent function. So in all these examples, the parent function is going to be y equals x squared. We're taking our basic quadratic function, we're describing what transformations are being done to go from our parent function to the given function. Okay? So for these examples, since we have a lot of information, what I recommend you do is you follow along with the table you have in your notes. Look at the table, listen to how I'm describing, identifying these transformations. Then when I get done with the example, you can go back and write down your notes. Okay, I recommend following along, looking at your table as I describe these examples. First thing I normally look for in these types of problems are vertical translations. Then I look for any horizontal translations. So for vertical translations, I'm looking at whether there's being a value added or subtracted at the end of the equation. So in this case, we have positive 1. We have 1 being added to the end of this function. If we're adding 1 at the end, that is a vertical translation up 1 unit. Next, I look at horizontal translations. which occur within our function, within the parentheses. So we have x minus 3. If we have x minus, our value is 3 we're looking at. So it's a horizontal translation, 3 units to the right. When we're describing these transformations, we want to make sure to be specific. So we want to say vertical translation up 1 unit, horizontal translation to the right 3 units. Don't simply say up 1 or right 3. Be specific on what transformations you're referring to. Now to the next example, we have y equals 2 times the quantity x plus 3 squared plus 2. Again, we're using the parent function. We have a quadratic, so we're looking at y equals x squared. What are we doing to that basic parent function to get to the given function? So first, I'm identifying any vertical translations. Looking at the end, we have 2, so we have a vertical translation up 2 units. Inside the parentheses, I see we have x plus 3. Think of this as x minus negative 3, so our value is negative 3. This is a horizontal translation, 3 units to the left. And then in the front, our function is being multiplied by that value of 2. So this is a vertical stretch. Our value of a, the absolute value of 2, is greater than 1. So this is a vertical stretch. So to specifically describe these transformations, we have a vertical translation up 2 units. There's a horizontal translation to the left 3 units. And then there is a vertical stretch by a factor of 2. Next example, we want to describe the transformations from our parent function y equals x squared. So we have the function y equals negative the quantity x minus 1 squared minus 4. This is a problem. Again, I'm looking at the end for any vertical translations. We're subtracting 4, so this means we have a vertical translation. We're moving every value down 4 units. Inside the parentheses, we have x minus 1, so we have x minus a value of 1. This is a horizontal translation to the right 1 unit. Now in this example, we have a negative out in front of our function. If there's a negative out in front of our function, that represents a reflection across the x-axis. So again, making sure to specifically describe these transformations. There's a vertical translation down 4 units, a horizontal translation to the right 1 unit, and then there is a reflection across the x-axis. Now to the last example. Same idea, except now we're looking at an absolute value function. So the parent function in this case is y equals the absolute value of x. What are we doing to this parent function to get to our given function? It follows the same pattern, the same rules as when we were dealing with the quadratic functions. I'm looking at the end. I'm adding a value of 3 that represents a vertical translation up 3 units. Looking within my absolute value signs, this refers to horizontal translations. It's x minus a value of 2, which means we have a horizontal translation 2 units to the right. Again, specifically describing these, vertical translation up 3 units, horizontal translation to the right 2 units. Now you have a couple examples that I want you to attempt on your own using your transformation rules.